Welcome back. Like we did in our previous class, we learned about mole concepts, and then I said we have four ways in which you can express moles. I said mole can be expressed in terms of formula. It can be expressed in terms of relative molecular mass or relative atomic mass. It can be expressed in Avogadro's number. It can also be expressed in terms of molar volume. So we are moving to the second one, which is in terms of relative molecular mass. Mole in terms of relative molecular mass or relative atomic mass. Now, in order to do this, we should know that 1 mole of any substance will be equals to relative atomic mass of the substance or relative molecular mass of the substance. So what it means is that 1 mole of any substance will be equals to relative atomic mass or relative molecular mass. That's what it simply means. So we should know that for us to know, we should know that 1 mole of magnesium will be equals to 24 per mole of 24 gram per mole. 1 mole of chlorine will be equals to 35.5 gram per mole. 1 mole of nitrogen is a diatomic atom, so it cannot stay on its own, will be 14 times 2, which is 28 gram per mole. 1 mole of carbon dioxide will be 12 plus 16 times 2 equals to 44 gram per mole, and so on like that, as you can see. So we're moving to the first example. We need to solve some examples. So we have to calculate the number of moles present in 27 gram of aluminum. You should not forget that the relative molecular mass of aluminum is 27. So in the solution, we already know that 1 mole of aluminum will be equals to relative atomic mass of aluminum. 1 mole of aluminum will be equals to 27 gram per mole of that. So in essence, therefore, 27 gram of aluminum contains 1 mole. So which means that it will just be, since 27 gram of aluminum contains 1 mole, so don't forget that calculate the number of moles present in 2.7 gram of aluminum. So since 27 gram of aluminum contains 1 mole, it means that 2.7 gram of aluminum will contain 2.7 over 27 gram times 1 mole over 1 to give me 0.1 mole of aluminum. That is that. So move to the number 2. To simply solve for number 2, we are to determine the number of grams of substance present in 0.1 mole of sodium trioxocarbonate for Na2CO3. So we should not forget that the molar mass of sodium is 23, molar mass of carbon is 12, molar mass of oxygen is 16. Like we previously did, 1 mole of sodium trioxocarbonate 4 will be equals to relative molecular mass of trioxocarbonate 4. So 1 mole of sodium trioxocarbonate will be 23 times 2 plus 12 plus 16 times 3. And so this can give us 106 gram per mole. So we should not forget that since according to the question we're given 0.1 mole of sodium trioxocarbonate 4 will contain 0.1 mole over 1 times 106 gram over 1. So we left 0.1 times 106, and that will give me 10.6 gram from here per mole from here. So for the third example, we'll be looking at how many moles of substance are present in 10.35 gram of lead. Atomic mass of lead, molecular mass of lead is 207. So don't forget that 1 mole of lead is equals to its relative atomic mass. So if 1 mole of lead is equals to 207 gram of lead, then 10.35 sorry, mistake. Then x, let me use x will be equals to 10.35 gram. 10.35 grams. So I cross multiply. My x comes to this one, becomes 207 gram x equals to 10.35 gram times 1 mole. So making x of the formula, x now becomes 10.35 over 207, and our answer should be 0.05 mole of lead. And that is it. That brings us to the end of today's class. Thank you for being part and joining us for today's class. Please, if you have not liked or subscribed to our YouTube channel, please do so. And in case you feel you want to ask any question that you're bothered about, please feel free to drop your question in the comment section below. Thank you.